We are going to discuss reducing power of the halide ions. I negative ion has more reducing power than Br negative ion, and Br negative ion is more powerful reducing agent than Cl negative ion. This phenomena can be tested by reacting these halide ion with concentrated sulfuric acid. When NaCl solid is allowed to react with concentrated sulfuric acid, there is the formation of HCl gas and sodium aqueous sulfate. Sodium sulfate aqueous formation take place. The observation of HCl gas is white or misty fumes. There is no further reaction. HCl does not react further with sulfuric acid. And this reaction is not a redox reaction. In fact, this reaction is the category of acid-base reaction and sulfuric acid behaving as an acid only. Sulfuric acid does not react with HCl gas to produce Cl2 gas. This phenomena cannot happen because sulfuric acid is a weaker oxidizing agent than Cl2. So any oxidizing agent that is the weaker one, it cannot produce stronger oxidizing agent than that of itself. Any oxidizing agent can bond, can make, can produce any other oxidizing agent that must be the weaker, not the stronger one. When we add sodium bromide solid with sulfuric acid, once again the reaction is similar as that of sodium chloride, and there is the formation of HBr gas and sodium sulfate aqueous. This HBr gas is having white fumes, it's shown like white fumes or misty fumes. This reaction is not a redox reaction, this first one, and it is said to be the acid-base reaction. But HBr once formed, it react with sulfuric acid, concentrated sulfuric acid, to make SO2 gas, Br2 liquid, and water formation takes place. This Br2 liquid is a reddish-brown liquid in appearance, so observation is reddish-brown liquid is formed, and a colorless gas is formed that is said to be the choking smell gas as well. This reaction is the redox reaction. Sulfuric acid reacts with HBr gas to make Br2 gas because sulfuric acid is a stronger oxidizing agent than Br2, bromine. You have to remember this equation, that is 2HBr plus H2SO4 goes to Br2 plus SO2 plus H2O. Sodium iodide is allowed to react with the concentrated sulfuric acid to make HI gas and sodium sulfate aqueous. Observation of the HI gas is misty fume. HI gas can react further with sulfuric acid in three different ways. First of all, it may make yellow solid, that is sulfur, H2O, and iodine gas formation take place. HI may react with different mole ratio with sulfuric acid to make SO2 and similarly H2O and I2. These iodine and H2O are the common product of all type of reactions of HI with sulfuric acid. HI may react with a different molar ratio with H2SO4, and now this time there is the formation of a rotten egg smell gas, that is H2S, water and iodine formation take place. First one reaction, is not a redox reaction, it's an acid-base reaction, and rest of the all reaction are said to be the redox reaction. In first reaction, that is a simple reaction as that of the previous one. The second reaction, in which there is the 6 mole of HI is going to react with 1 mole of sulfuric acid, 2 mole of HI is going to react with 1 mole of sulfuric acid, and 8 mole of HI is going to react with 1 mole of sulfuric acid. So every time we are using 1 mole of sulfuric acid and HI is in different mole ratio, you can say 2, you can say that's the even mole ratio, 2, 6, and 8 mole ratio. H2O, I2 is the common product of all these reactions, but the product is because of the sulfur element, sulfur solid is formed, SO2 may be formed, H2S may be formed. These all reactions are said to be the redox reaction. If the iodine is being formed in form of solid, it's a black solid. If it is being made or you are going to report this iodine as a gaseous vapors, then its color will be the purple and so on. You can also report this iodine in form of aqueous because the water is being formed at the moment, and obviously there will be small quantity of water as well. So at that time you will write it, its observation will be brown solution. Why this reaction happens basically, why HI is going to react with the sulfuric acid. Sulfuric acid react with HI to make iodine gas or iodine solid or iodine aqueous solution. Because sulfuric acid is more powerful oxidizing agent as compared to the iodine. That's why this reaction is going to happen. Now come towards the thermal stability. HCl, HBr and HI can be tested their thermal stability by heating or by introducing a hot rod into the sample of these gases. Hydrogen iodide easily decomposed into the element by dipping a red hot wire into the test tube containing HI gas. HBr may or may not be decomposed depending on the temperature of that wire. But HCl and HF never decomposes. This is because the strong bond enthalpy of these hydrogen halides. HCl having the stronger bonds, HBr has the medium bond strength, and HI is having lowest bond energy or bond strength. In this reaction, red hot wire that is inserted in the sample basically provides energy of activation for the reaction. Uses of the halogens. Fluorine. In chlorofluorocarbons, used as aerosol propellant, refrigerant, and as a foaming agent in the polymers. CFCs are also used in artificial blood, PTFE polytetrafluoroethene, lubricants, non-sticking cooking or fry pans, and tin fluoride SNF2 used in the fluoride toothpaste. The next one is chlorine, that is also used in CFCs, that is used to make PVC pipe, polyvinyl chloride pipes, used as a solution, as a bleaching powder, in household bleach, and it is also used to treat the drinking water to kill bacteria, like in swimming pools. Bromine, in case of 1,2-dibromoethane, it is used as a petrol additive. Bromochloromethane is used as a fire extinguisher. Silver bromide is widely used in a photographic film. The last one is iodine. A solution of iodine in alcohol can be used as a mild antiseptic agent, and iodine is an essential part of our diet.